Hello students, welcome to the class. Our next topic is gravitation. So in gravitation, we will study what do you mean by gravitation, what do you mean by gravity, what is acceleration due to gravity, what is the Newton's law for this gravity. Okay, so how the law is developed, Kepler's laws, what is the history behind the Kepler's laws, then how the acceleration due to gravity will vary from place to place, then what is weight, how it differs, what are the factors it is affecting, then acceleration due to gravity, how it will vary from place to place, that we will see. Okay, so these are the content of this chapter, except that we will study regarding escape velocity, then orbital velocity, satellite, types of satellite. These are the contents of this chapter. Okay, so let us start with our first class with the synopsis. So first we have, what do you mean by gravitation? See here, when we talk about gravitation or a gravity, it is a natural or occurring phenomena or a force which exerts among all material objects in the universe. So what is the meaning of this one? See, as we know that in the universe, all the bodies in the universe attract each other, right? So all other bodies attract each other bodies here. That is nothing but what? That is because of gravitational force. That is because of gravitational force. Okay, so all the objects attract the other objects because of the gravitational force here. Okay, if you see between the earth and the sun, the ball thrown up, every objects attract each other here. Gravitation is one of the four classes of interactions which is found in nature. Okay, so gravitation is what? It is the interactive force. We say that this gravitation is what? Interactive force. So how can you say that the gravitation is a interactive force? Let us see. That is, here, suppose if one object is there and this is one more object, and consider this object mass as m1, this object mass as m2. Why the gravitation force is called as the interactive force? Because here the first body exerts force on the second body, as well as the second body exerts force on the first body. So this is called as what? This is nothing but what? Gravitation or gravitational force. Gravitational force here. See here, there are four fundamental forces in nature. So we have four fundamental forces in nature. The first one is a gravitational force, then second one is a electromagnetic force, then third one is a strong nuclear force. It is also called as hadronic force. Then the fourth force is weak nuclear force. So compared to all these four forces in nature, gravitational force is the weakest force among all four. Okay, you might have studied regarding muscular force, frictional force, then nuclear force, and you have solar and forces. So we have different forces here. Out of all the forces, these four are called as what? Fundamental forces. These are what? Fundamental forces. Okay, so in all these four forces, the gravitational force is having the least value. The gravitational force is having the least value. This is called as what? Gravitational force. Is it clear? So this is regarding the gravitational force. So regarding other forces, we will discuss in our that is physical world and units and dimension chapter. Okay, so see here, next point, Newton's law of gravitation. So what is Newton's law of gravitation here? Newton's law of gravitation states that, so here how this law come to an existence, that is when Sir Isaac Newton was sitting below the apple tree, so the apple falls on him. So from there the gravitation concept is developed. So based on that, he will give the law, he will make his model by the study of that, he will give the Newton's law of gravitation. So this gravitational force, it is an attractive force between two masses m1 and m2. We say that the gravitational force is what? It is the attractive force between two bodies, always the gravitational force is the attractive force. Never the gravitational force is called as repulsive force. Why it is never called as repulsive force? Because here attractive force means what? The one object attracts the other object. Repulsive force in the sense they will repel each other, but always the any objects if you take in the universe, they will attract each other. Okay, then how this gravitational law or universal gravitational law is defined? That is, suppose if you take two bodies, I'll draw here. So if I assume this is A body of mass m1, then if I take this as B body of mass m2, they are separated by a distance of r. They are separated by a distance of r. Then according to the law of gravitation, it can be defined as here, as I said you, the gravitational force is what? The one body exerts force on the other body. The second body exerts force on the first body is called as what? Gravitational force. So whatever the force between these two bodies are there, the force between these two bodies, I'll take it as F. So this force, the force between the two bodies, is proportional to product of the masses. These two forces is proportional to product of the masses, and it is separately I'll write it as equation 1. The force between the two bodies is proportional to product of the mass, and the force between two bodies, it is inversely proportional to square of the distance between them. So this is called as what? This statement is nothing but what? Inverse square law. This statement we call it as what? Inverse square law. So what is inverse square law? Inverse square law is nothing but here the force between the two bodies, it is inversely proportional to the square of the distance between them, is called as inverse square law. Is it clear what is inverse square law? Okay, means the force between the two bodies, it is inversely proportional to square of the distance between them. That is called as inverse square law. So the gravitational force statement is what? Universal law of gravitation. The statement is the force between the two bodies, it is directly proportional to the product of the mass, and it is inversely proportional to the square of the distance between them. Now by combining this equation 1 and 2, we can write it as F is proportional to m1 into m2 divided by r square. So by combining equation 1 and 2, we can write it as F is proportional to m1 into m2 divided by r square. Now we can remove the proportionality sign. We can take equal sign by taking some constant. So here the constant I am taking it as G. This G is called as, first I'll complete this equation, G m1 into m2 divided by r square. G m1 into m2 divided by r square. So here G is called as universal gravitational constant. G is called as universal gravitational constant. Okay. So the law is called as Newton's law of gravitation, or it is also called as universal law of gravitation. We call in both the ways. See here. So the expression for universal law of gravitation is, so this is the final equation, that is F is equal to G m1 into m2 divided by r square. This is what? This is the universal gravitational law. Correct? Okay. M1, M2 are the mass of the bodies. R is the distance between them. If you want, you can take the distance as d also. So this is the statement for universal law of gravitation and the expression for gravitational law. Here you can see the statement is written. The gravitational force acting between two point objects, it is proportional to the product of their masses and inversely proportional to the square of the distance between them. It is inversely proportional to the square of the distance between them. That is called as universal gravitational law. Right? Next. See here, you can see the figure. That is two bodies of the masses m1 and m2. The distance between them, we take it from the center, that is taken as r. Then here it is F. Correct? Then next. So important points about gravitational force. What is a gravitation force here? That is, gravitational force is a central as well as conservative force. See students, in the work and energy chapter, we have discussed already about conservative force. So what do you mean by conservative force here? Conservative force is nothing but, that is, here it can be defined as if the force is independent of the path followed by the body. Force is independent of the path followed by the body is called as conservative force, is called as conservative force. Okay, so this gravitational force is a conservative force. Means, suppose if you throw one object, as I told you while discussing in the conservative and non-conservative forces, we discussed at this point already. That is, suppose if the object is placed here, I want to keep it at this point. What I can do directly, I can take it from here and I can place it, or I can take it from here to here, then again from here to here, then here, then here, then we can bring it to this point. So this gravitational force is what? It is the conservative force. Means either you can take it this way or you can take it this way. It does not depend on the path followed by the body. So this is example for gravitational force. So gravitational forces are called as what? Conservative force. It is called as conservative force. See here students, they have said it as a central force. So what is central force here? Central force is nothing but, suppose if you consider this as one body, this is the center of the mass of the body, and this is second body, this is the center of the mass. The distance between them, suppose if I take it as r, if I take it as r, then here what happens, whatever the distance between them it is there, this is acting, means the force is acting along the center of masses. So such forces are called as what? Central forces. Such forces are called as what? Central forces. Therefore we say that the gravitational force is a central force, means along the axis, you can see here center. So along the axis of line joining, the force will act. Therefore it is called as what? Central force. Therefore it is called as central force. Is it clear? Next. Second point. It is the weakest force in nature. Gravitational force is what? It is the weakest force in the nature. So why it is called as weakest force in the nature? As I told you, among all the four fundamental forces, the gravitational force is the weakest force among all four forces. Okay. So next, it is 10 to the power of 36. It is not 10 raised to this. Okay. It is here. This is in the power. So this quantity is in the power 36. So it is 10 raised to 36 times smaller than electrostatic force and 10 raised to 18 times smaller than the nuclear force. As I said you, this is the weakest force among all four fundamental forces in nature. This force is what? 10 raised to 36 times smaller than electrostatic force and 10 raised to 18 times smaller than the nuclear force. And the law of gravitational is applicable for all bodies irrespective of their size, shape and position. Here the law of gravitation is applicable for all the bodies. The law is applicable for all the bodies irrespective of their size, shape and position. Is it clear? Means here whatever may be the shape of the body and whatever may be the size of the body, the gravitational force does not depend on size, shape and position. Okay, so position in the sense either you keep it here, here, wherever you keep, it does not depend on the position, it does not depend on the shape, it does not depend on the size. That is the fourth point regarding gravitational force. Fifth point, the gravitational force acting between sun and planet provide it centripetal force for orbital motion. Meaning is here, So you can consider this as sun and this as the planet. This as the planet. So whatever the planets are revolving around it, the sun here, whatever it is there, sun and planet it is. Here the between the sun and the planet, whatever the gravitational force exists between the sun and the planets, the gravitational force exists. This acts as what? Centripetal force, or it provides necessary centripetal force for the body. Okay, then sixth point, gravitational pull of the earth is called gravity. So here the gravitational pull of the earth is called as what? Gravity. Means whatever the force of attraction between the earth and the other object is there, in we call it as gravity. The next point, Newton's third law of motion holds good for the force of gravitation. So Newton's third law of motion holds good for this force of gravitation. Means it means that gravitational forces between the two bodies are action reaction pair. So what is Newton's third law? Newton's third law is what? So action and reaction are equal and opposite. In the same way, here if two bodies are there, whatever this body exerts force on the other body, this must be equal to the force exerting by second body on the first body. Here the forces are equal. The forces are equal, but they are in the opposite direction. You can see first body, suppose if it is exerting force on right side, the second body is exerting force on the left side. So we say that the forces are equal in magnitude, opposite in direction, and it is a action reaction pair. So here students, these are the points which we need to remember for gravitational force properties. So what are the points here? That is, gravitational force is a central force as well as a conservative force. It is 10 to 36 times smaller than the electrostatic force and 10 to 18 times smaller than the nuclear force. It is the weakest force in nature. It is the weakest force in nature. And the law of gravitational is applicable for all bodies, irrespective of their size, shape, and position. So this gravitational force acting between the sun and planet provided centripetal force. It provides centripetal force for the orbital motion. And this obeys Newton's third law. It obeys Newton's third law. So these are the few points about the gravitational force. Next, acceleration due to gravity. So what do you mean by acceleration due to gravity? Acceleration due to gravity is nothing but the uniform acceleration which is provided in a freely falling object due to the gravitational pull of the earth is known as acceleration due to gravity. What do you mean by acceleration due to gravity? The acceleration produced in a freely falling object due to the gravitational pull of the earth is known as acceleration due to gravity, is called as acceleration due to gravity, and it is denoted by the letter small g, and the unit is meter per second square. Right? So the definition of acceleration due to gravity is the freely falling body, whatever the acceleration it acquires, it is called as acceleration due to gravity. This is denoted by the letter small g. So don't get confused between capital G and don't get confused between capital G and this small g. Why? Because capital G is what? Universal gravitational constant. Small g is what? It is acceleration due to gravity. This is acceleration due to gravity. Here, the unit of this g, that is small g, is meter per second square, because as it is a acceleration itself, okay. So just one point I want to tell you about our equation. F is equal to g into m1 into divided by r square. So here we have equation of that is a gravitational force as F is equal to G into bracket m1 into m2 divided by r square is our expression. Here, as I said, G is called as what? Universal gravitational constant. I can simplify this equation 1 for capital G also. So capital G is equal to, I can write it as F into R square divided by M1 into M2. F R square divided by M1 into M2 is equal to G. Correct. So this is what the value of gravitational constant. So by Cavendish experiment, we can calculate the value of this capital G. Okay, so Cavendish experiment, at the end we will just discuss that. Okay, so Cavendish experiment will give you the value of capital G, and the value is found to be 6.67 into 10 raised to minus 11. The value is 6.67 into 10 raised to minus 11 is the value for capital G. Small g value is how much? It is acceleration due to gravity. Its value is 9.8 meter per second square. So here students will see the what is the unit of this capital G. The unit of force is given as Newton. The unit of distance is written as meter square. It is divided by. The unit of mass is kg into kg. So kg into kg is what? Kg square. Therefore, it can be written as Newton meter square per kg square is the capital G. It is the capital G unit, Newton meter square per kg square. So as here I have written the unit value as 6.67 into 10 raised to minus 11. Unit I'll write it as Newton meter square per kg square. Then what is the dimensional formula here? See here, the dimensional formula is written as is equal to, sorry. So here it is equal to dimensional formula for force. It is ml t raised to minus 2, right? So dimensional formula for L, it is L, but R square it is, therefore L square L, right? Divided by m raised to 2. So I can simplify it as m divided by m raised to 2 is there, therefore it becomes m raised to minus 1. L raised to 1, L raised to 2. That becomes L raised to 3, t raised to minus 2. So this is what the dimensional formula for your universal gravitational constant capital G. Is it clear? So this is the unit, value and the dimensional formula for universal gravitational constant. Okay, students? So we were discussing about acceleration due to gravity. Let's go back to that point. This is acceleration due to gravity. Okay. See here, already definition we have discussed, unit also. Then next, so this acceleration due to gravity, it is a vector quantity. See the next point, they have given that acceleration due to gravity, it is a vector quantity. Why? Because as acceleration depends on magnitude and direction both, therefore it is called as vector quantity, and its direction is towards the center of the earth. It is, its direction is center of the earth. The value of G is independent of the mass of the object which is falling freely under gravity. Okay, so here we say that the value of small g is independent of the mass of the object which is falling freely. Means, suppose here if you take two objects, one is of smaller size and the other one is of bigger size. Here what if you drop these two objects from the same height? Okay, if you drop it from the same height, both will reach the surface of the earth on at the same time. Why? Because here whatever the acceleration due to gravity is acting on this body or this body, it is independent of the mass. It does not depend on the mass of the body. Okay, so in the next slide we have the expression. There you will get to know why and how it does not depend on the mass of the body. Okay, the value of G changes slightly from place to place. The value of this G changes from place to place. Means, for example, if you are measuring your that acceleration due to gravity At the equator of the earth, then the value is little different. At the pole it is different, and if you take in between any places, the value will change slightly, very small amount it will change. Okay, it is not like one place it is 9, one place it is 2, one place it is like 12, not like that. Very small change in the value will be there for G. Next, the unit is, that is the meter per second square, and the value is found to be 9.8 meter per second square. So in the next slide we will be seeing how this value comes. Okay, next. So sometimes we will round up and take this 9.8 as 10 also. Sometimes we take it. The value of acceleration due to gravity on the moon is about 1/6 of that of the earth, and sun is about 27 times that of the earth. So what is the meaning of this? They are saying that suppose the acceleration due to gravity of the earth, and acceleration due to gravity of the moon, and acceleration due to gravity of the sun, these relations they are saying. So what they are saying, see here, the 1/6 means the acceleration due to gravity, on the moon, it is 1/6. It is the value of 1/6 that is taken as, suppose G is the value of acceleration due to gravity on the earth. It's 1/6 means divided by 6 is equal to acceleration due to gravity on the moon. And on the sun, it is about 27 times. On the sun, suppose this is acceleration due to gravity on the sun, is equal to 27 times acceleration due to gravity on the earth. Means suppose if it is 9.8 on the earth, so 9.8 divided by 6, 1/6, it's the sixth part is on the moon, but it is 27 times on the sun. Is it clear? So this is what acceleration due to gravity at different places. Again, we will discuss the factors also. So let's see next slide. Next, among the planets, the acceleration due to gravity is minimum on the Mercury. The relation between small g and a is given by. Among the planets, the acceleration due to gravity is minimum on the Mercury. Means whatever the planets are there, so whatever the 8 planets are there, in all the 8 planets, Mercury is having the minimum value of acceleration due to gravity. Mercury is having the minimum value of acceleration due to gravity. So here, next we have the relation between acceleration due to gravity G and capital G. This is not A. So here it is capital G, that is gravitational constant. So this is G itself, but here it is capital G. We will see the relation between them. How we will do this? That is, see, as we know that F is equal to G into bracket, I'll take it as capital M into small m divided by R square. So what it is, if I take two objects, one is having mass small m and the other one is having capital M. The distance between them along the center, along the line joining, suppose the distance, if I take it as capital R instead of small r. Now this is the gravitational force between them, can be written as equation 1. It can be written as equation 1. Now I'll write according to Newton's law, we have the force on the object is given as F is equal to m into G. Why G here? What is G? G is nothing but what? It is acceleration due to gravity. Instead of acceleration A, I am taking it as G. Right. Now I can simplify this equation for G is equal to. So this can be written as F divided by small m. Small m is the mass of the object. Capital M is the mass of the earth. Substitute the value of F from equation 1. So what is the value of F here? The value of F is G m into m divided by r square, and this whole divided by m is equal to small g. So this m will get cancelled. Therefore, we will get it as gm divided by r square is equal to g. This is what the relation between capital G and small g. The relation between capital G and small g. Okay, so capital M is what? This is the mass of the planet. It is mass of the planet. You can see in the given expression, mass of the object term is not there. That is, small m term is not there. What is the meaning of this? When small m term is not there, we say that your G value, that is acceleration due to gravity value, does not depend on the mass of the object. It only depends on the mass of the planet. Okay, that is gm is divided by r square. So here in the equation, you can take divided by capital R, you can go for small r, you can take d also. The choice is yours. So m also, according to your convenience, you can consider. Now you can see down it is written where m is the mass of the earth. So the mass of the earth is 6 into 10 raised to 24. Okay, don't get confused here. That is 10 raised to 24. It is not 1024. It is 10 to the power of 24. Right? That is in kg. Next, radius of the earth is 6.38 into 10 raised to 6 meter. Therefore, acceleration due to gravity at a height h above the surface of the earth is given by. So here, what they have calculated in the theory part, you people have studied this. So here, direct expression is there. You need to remember this, that is acceleration due to gravity does not depend on the mass of the body, and the relation between them is given by gm divided by r square. Next, so here next they have given that at a height h means, suppose here if you consider the earth, here if you consider the earth which is having acceleration due to gravity g, okay, mass is capital M. Now I'll consider some object which is at height from the earth at h, means from the surface of the earth it is at a height of h. So from the center of the earth, this distance is nothing but what? Radius of the earth, that I'll take it as capital R. So students, can you see this? What is the total distance here? The total distance becomes what? R plus h. So total distance in the sense, it is the distance between the center of the earth to the object. It becomes R plus h. Now the total distance becomes r plus h. Therefore, acceleration due to gravity g is equal to. So how we can write? As we know that acceleration due to gravity g is equal to, what was our expression? Just now we saw it is gm divided by r square. Now when the acceleration due to gravity, you are taking it at a height of h, this gh is equal to, it will become g into m divided by total distance is what now? It is r plus h. But as it is r square, here it becomes r plus h square. It becomes r plus h square. Now if I take the ratio of gh divided by g is equal to, so what is gh by g? Gh is what? Acceleration due to gravity at a height h. G is what? Acceleration due to gravity at the center of the, means on the surface of the earth. Suppose if you take the ratio, you can see here, that is gm will get cancelled. Therefore, you are left with only what? R square divided by R plus H whole square. Now here we can take common, then we can expand it by using A plus B whole square formula, and we can simplify this. So if I simplify this, directly I am telling you the expression now. I am not going to simplify this. Okay, because we need only formulas for the competitive classes. The formula is GH is equal to G into bracket 1 minus 2H whole divided by R. This is the expression for acceleration due to gravity when the object is at a height of H. Correct? So your expression is what? GH is equal to G into bracket 1 minus 2H divided by R. So as it is written, 1 minus 2H, 1 minus 2H, which means that, see, if I multiply this equation, that is, our equation is what? GH is equal to G into bracket 1 minus 2H divided by R. So if I multiply, it becomes what? G minus 2GH divided by R, means it is 9.8 minus some value. So here, can you guess the value will decrease or increase? As it is written 9.8 minus, the value is decreasing. The value is decreasing. So 9.8 minus some value. Therefore, here acceleration due to gravity at height h, it decreases. So what we can conclude from the expression? We can conclude that acceleration due to gravity decreases as we go above the surface of the earth. As it is going up, the acceleration due to gravity decreases. So this is regarding what? Acceleration due to gravity at height h. So how much it decreases and all, it depends on your h value, because in the expression, if you see, G is constant, that is 9.8, right? G. Then R, radius of the earth, is also constant. Only variable is h, means at what height you are placing the h, means object. Based on that, your acceleration due to gravity will change. Is it clear? The next question, I mean next slide. Factors affecting acceleration due to gravity. Factors affecting acceleration due to gravity here. That is, first one, that is shape of the earth. So shape of the earth is one of the factor which will affect your gravity. Okay. So shape of the earth, how it will vary? See here. As you know that the earth is in the elliptical in shape. Earth is in elliptical in shape. If you see that the radius of the, so here I'll show you the one rough diagram. So if you see the earth, it is something like this. Here if you see the radius or the diameter, this is what? This is equatorial line, and this is, these are the poles. These are what? Poles here. Okay, so if you consider the equatorial radius is, if you consider the equatorial radius is 42 kilometer greater than the radius of the, here it is written, see, that is, earth is elliptical in shape. The diameter at poles is approximately 42 kilometer less than its diameter at equator, means equator diameter is more than the pole's diameter. Okay, 42 times. Therefore, what we can say is, here they have given the statement like G is minimum at equator and maximum at poles. G is minimum at equator and maximum at poles. So here I will say that by the expression, that is, the expression is what? G is equal to Gm divided by R square. G is equal to Gm divided by R square. So what I said, the radius of the equator is more. The radius of the equator is more means, so this value will be more. As the expression R and G are inversely related, this value what happens? This value decreases. Therefore, acceleration due to gravity at the equator is decreasing. So when the acceleration due to gravity value is decreasing at the equator, the acceleration due to gravity at the poles will be maximum. So G is minimum at equator and maximum at the poles. So why it is minimum, why it is maximum, I told you from the expression, because our G value is inversely proportional to square of the distance between the objects. As the distance decreases, acceleration due to gravity value increases. So this is the concept, how your acceleration due to gravity will vary due to the shape of the earth. Okay, next point. Rotation of the earth about its own axis. If omega is the angular velocity of rotation of the earth about its own axis, then acceleration due to gravity at a place, having latitude lambda is given by. So direct expression you have, just see the expression. That is G dash is equal to G minus R into omega square. Okay, so first factor is what? Due to the shape of the earth. Second factor is what? Due to the rotation of the earth, due to the axis of rotation. The expression is given by G dash is equal to G minus R omega square cos square lambda. Sorry, it is coming, it came down. It should be actually G minus R omega square cos square into omega. Cos square theta, like that, cos square omega I have taken. Okay, so if you substitute the value of lambda is nothing but it is the value of angle. So if you can take it as theta also, you can take it as theta also. Okay, therefore at the poles here what happens, the angle is 90 degree, therefore G dash is equal to, we will get it as G. Why we are getting G dash is equal to G? Because cos 90 is how much? Cos 90 is 0. So therefore R omega square term becomes 0. Therefore G dash is equal to G is the answer for poles. Next, therefore there is no effect of rotation of earth about its own axis at the poles. At the equator the angle is 0. So when angle is 0, cos 0 is 1. Therefore the equation becomes G dash is equal to G minus R omega square. So in the above step what I said here, due to the shape, at the poles it is maximum and at equator it is minimum. Similarly, due to the angle also you can conclude that at the poles it is maximum because it is only G dash is equal to G, means G dash is equal to 9.8. But at the equator it is G dash minus R omega square. So it depends on rotation omega. It depends on the omega value. Okay. So this is what the factors affecting the acceleration due to gravity. Already we have discussed how with the what we can say, that is shape it will vary due to the axis of rotation, and due to the height also we have discussed. Then the next slide is So due to the rotation of the earth, the equation is G dash is equal to G minus R omega square cos square lambda. So if the objects are at poles, object is at pole, here the theta value becomes 90 degree. So when theta is equal to 90 degree, cos 90 is 0. Therefore, we will get G dash is equal to G, right? That is at the poles the value is same. And here you can see at the equator, there is no effect of rotation of earth about its own axis at the equator, at the poles. At the equator, the value of theta becomes, or lambda becomes 0. So cos 0 is 1. Therefore, the equation becomes G dash is equal to G minus R omega square. Here you can see that it becomes 9.8 minus. So minus of this radius and this angular velocity, right? As the value of this acceleration due to gravity decreases, because we are subtracting some value from 9.8, therefore we can say that at the equator, the acceleration due to gravity is minimum, and at the pole it is maximum. So due to the axis of rotation and due to the shape, we are proving the same concept here, right? The next factor which is affecting acceleration due to gravity is okay. So next is effect of altitude. The value of G at height h from Earth's surface is given by, this is G divided by 1 plus h by r whole square. So in the previous slide, we have seen already the expression for the object when it is at certain height. So the expression is what? That is G dash is equal to G into bracket 1 minus 2h divided by r. So this is what simplified form. So the previous equation of this simplified form, we will get it as G dash is equal to G into bracket 1 G divided by 1 plus h by r whole square. Okay, so this is the simplified form which we are seeing here. So this is the previous step. Here we will apply binomial expansion and we will simplify this. Then we are getting this step. We are getting this step. Okay. As again the value of G is decreasing, we say that the effect of altitude is what? That is the G value decreases with altitude, right? So these are the factors which affect the value of G here. First one is due to the shape and size of the earth. Then next we have due to the axis of rotation of the earth. Then next due to the altitude or the height h. The next point we can say at a depth. So effect of depth, what happens to the value of G? That is G dash is equal to G into bracket. The equation is 1 minus h divided by r. So you can also write it as G dash is equal to G minus, means you can multiply this G inside the bracket, therefore it becomes GH divided by R. Or we can take G common also. Again, you can see here the value of G, that is 9.8 meter per second square. Again, it is decreasing. So we can say that the value of G decreases as we go down also. So the conclusion of all the 4 points is at the poles, the G value is maximum. At the equator, the G value is minimum. And next, as you go above the surface of the earth, the G value is again, it is decreasing. And again, when you go down, means at a depth of D, the value of G decreases. So here, then where the value is constant or where it is 0, let us see that the value of G is 0 at the center. The value of G becomes 0 at the center of the earth. Why? Because here you can see the equation G dash is equal to G into bracket 1 minus h by r. As I said, at the center of the earth, we will take this h is equal to r. So if I substitute h is equal to r, it becomes 1 minus r divided by r. So this one will get cancelled. That is nothing but Here it is 1. It is not 0. Here it is 1. So 1 minus 1, it is 0. G into 0 is what? It is 0. Therefore, we say that G dash is equal to 0. So the conclusion is what? At the poles, it is maximum. At the equator, it is minimum. As you go above, G value decreases. As you go at a depth, then also it decreases. At the center, it is 0. So we say that on the surface of the earth, the value is maximum. Okay. The next point we have, that is gravitational field. So what do you mean by gravitational field here? The space in the surrounding of any body in which its gravitational pull can be experienced by other bodies is called gravitational field. What is the meaning of this? Means here, suppose this is the earth. If any object is nearer to this, you can say that according to the gravitational force definition, the bodies will get attracted towards each other. Again, if you keep at some distance, it may get attracted to each other. So if you keep the object little far from this, here only up to particular region, this gravitational force is acting. If the body goes above that field, above that region, the force will not act, the gravitational pull will not be there. So up to what range the force is acting? Up to what range the force is acting, the gravitational force is acting on a body is called as what? Gravitational field. So field in the sense it is a region up to which the gravitational force is acting on a body is called as gravitational field. Is it clear? So you can take one more example. Suppose if you throw any object with certain velocity, with certain force, it from here it will go certain height and then it will return back. I'll increase the velocity and force, it will go little more height, again it will return back. Then if I increase in such a way that it will escape out of the gravitational force where the gravitational force is not acting, so up to this region, up to certain region, this force is acting, that is called as gravitational field. Is it clear? So this is regarding the gravitational field and the factors affecting the acceleration due to gravity. So till now we discussed what do you mean by gravitation, what do you mean by gravitational force. Then next, Newton's universal law of gravitation is over. Then what do you mean by acceleration due to gravity? What is the definition, the value, then the factors affecting acceleration due to gravity. These all points we have discussed. Then next. The next is intensity of gravitational field. So the gravitational force acting per unit mass at Earth, any point in the gravitational field is called intensity of gravitational field at that point. So what is intensity of gravitational field? In simple words, we can say that this intensity of gravitational field is the ratio of force and mass. The ratio of the gravitational intensity or intensity of gravitational field is equal to force per unit mass is taken as intensity of gravitational field. We can define it as force acting per unit mass at Earth at any point in the gravitational field. So already you know what is gravitational field, up to certain region. So here whatever the force it is acting, that force per unit mass is called as intensity of gravitational field. It is denoted by I. Intensity of gravitational field is written as I. So in some of the books we can see that it is written as E suffix G. Okay. So what may be the unit here? The force is measured in terms of Newton and mass is measured in terms of kg. Therefore, it is Newton per kg. We can take it. Okay, this is regarding the intensity of gravitational field. So remember the formula. Either we can calculate intensity or we can calculate mass or we can calculate force also. Next, that is intensity of gravitational field at a distance r from a body of mass m is given by. here we are taking the value of F. So what is our expression? The expression is F is equal to, we will take F is equal to G into M divided by R square. So our intensity formula is what? F divided by small m. I can write the value of F here. I can substitute, that is Gm into M divided by R square whole divided by M. So mass term will get cancelled, that is mass of the object is equal to Gm divided by R square. Here the intensity we have taken in terms of distance and gravitational constant. So we have two equations. One is in terms of force and mass, and another is in terms of gravitational constant and distance. Here you can see that as it depends on force, we can say that it is a vector quantity and its direction is towards the center of the gravity of the body. The direction of this intensity of gravitational field is towards the center of gravity. Okay, the SI unit already I told you, it is Newton per meter, and its dimensional formula is taken as LT raised to minus 2. The dimensional formula is taken as LT raised to minus 2. So if you want, you can calculate the dimensional formula. See here. So we have I is equal to forces MLT raised to minus 2 divided by M. So M we can cancel and we can write it as LT raised to minus 2. Right. So this is the dimensional formula for intensity of electric field. Okay, unit also we can see. Force can be written as, it is kg meter per second square divided by kg, right? So or in short we can take it as Newton per meter. In short we can take it as Newton per meter. The gravitational mass mg is defined by Newton's law of gravitation. That is mg is equal to Fg by g. So Fg is what? It is W by g. That is weight of the body divided by acceleration due to gravity. So here we have one more equation that is the relation between mass and force. Fg1 g2 divided by Fg2 g1 is equal to m1 into g and m2 into g. So this is what this is what gravitational mass mg formula. Okay, so gravitational mass is taken as m into g. That is nothing but weight itself. That is nothing but weight itself. Okay. Next slide, that is gravitational potential. So what do you mean by gravitational potential? Gravitational potential at any point in gravitational field is equal to the work done per unit mass in bringing a very light body from infinity to that point. So this gravitational potential, you can take it as, so here you can assume this as earth and some object is placed which is not in the gravitational field, so to bring this object within the gravitational field, suppose if you take two charges, one is positive charge and the other one is negative charge, you know that they will attract each other because unlike charges attract each other. So if you take two positive charges, they will start repelling each other, or two negative charges also, they will start repelling each other. To bring these two charges close to each other, so these two charges close to each other, you need to do some extra work here. You need to do some extra work, or extra force must be applied. Here the gravitational potential is what? Whatever the work you are doing to bring this body within the gravitational force. Within the gravitational force per unit mass is known as what? Gravitational potential. Gravitational potential is nothing but it is a work done in bringing a body from infinity to a gravitational field, and the body is having light weight. Okay, so that is called as what? Gravitational potential. So this gravitational potential, some books denote it by U and some we can take it as Vg, that is gravitational potential. Okay, so here we have the expression for gravitational potential. As I said, it is the ratio of what? Work done per unit mass. It is work done per unit mass. W by m. W is equal to, we can substitute in terms of that is gravitational constant and mass of the planet, that is gm divided by r. If you simplify the equation, the final expression for gravitational potential is gm divided by r it is. Okay, so here the SI unit is joules per kg. The SI unit is joules per kg is the unit, and it is a scalar quantity. The gravitational potential is a scalar quantity, and the dimension formula, already you know how to calculate the units and the dimensional formulas. Here the dimensional formula is L raised to 3 and R raised to minus 2, and SI unit is joules per kg. Since work W is obtained, that is it is negative, the gravitational potential is always negative. Okay, why? Because here you are doing the work opposite to the direction of the gravitational force. The gravitational force is acting in one direction and you are doing the work in opposite to that, therefore it is always negative. Here the gravitational potential energy of any object at any point in gravitational field is equal to the work done in bringing it from infinity to that point. Here gravitational potential energy definition is given. It is the work done in bringing the body from infinity to that point. Okay, so the expression for gravitational potential energy is minus g m into m, that is mass of the planet into mass of the body, divided by distance between them. Here the negative sign shows that the gravitational potential energy decreases with increase in the distance. So you can see the expression, it is written as U is equal to minus G m into m divided by r. As it is in the denominator, the r value is in the denominator. When r value decreases, the gravitational potential energy increases with the distance. Okay, gravitational potential energy at height h from surface of earth, it is given by UH is equal to minus G m into m divided by r plus h. Okay, or we can also write it as mgr divided by 1 plus h by r. That is what gravity, here expression is g mm by r. So instead of taking r, we are taking it as r plus h. So further again, if I simplify, it will become mgr divided by 1 plus h by r. So this is regarding the gravitational potential and gravitational potential energy. So we have discussed what is gravitation, gravitational force, universal law of gravitation. Then next, the factors affecting acceleration due to gravity, how it will vary, and then gravitational potential energy. So these all concepts we have discussed today. In the next class, we will continue with what do you mean by escape velocity, what do you mean by orbital velocity, satellites, types of satellites, and Cavendish experiment. Okay, so in the next class, we will continue. Thank you.